Hello, this is Dr. Mears. Today we are going to be filling out our definition sheet for our ISN on the system of linear equations. And what I want you to notice, I put this little page number here, it's page 64. In your ISN, it's going to eventually look like this, where 64 is the definition of a system of linear equations. And there's also going to be two more videos coming up after this, which will be on page 65 for solving by graphing and 66 solve by substitution. So this is what it will eventually look like. If you're a page or two off, please don't worry about it because I know a lot of you wanted to put review pages, but that's just what's coming up. So that next page that you're on, you're going to want to put the system of linear equations definition. So I hope you all have your definition sheet. Let's start. In my last video, what I did is an introduction into systems. So I just want to put everything on one page so you see how it works out. So I want to put the definition, give you an example of the types of solutions, tell you about the characteristics, and give you a non-example. So here we go. Definition for system of linear equations is two or more equations working together. That's it. Let's write it. And we're done. The characteristics. We have solutions to systems. So the solution is the ordered pair that makes both equations true at the same time. So what type of solutions do we have? That's what I'm going to show you in the example. So in the example, we can have first one solution. And if you remember, one solution is where they meet at a point, or they cross or intersect. Those words are really good to use. So here's my x and my y. And what I'm going to do is I'm going to draw a little picture of two lines, and I'm going to demonstrate that they intersect, they meet, they cross right here. So here is their point where they meet. And their point is an xy coordinate, and that's where they meet, at that xy coordinate. Another type of solution that we have is no solution. Again, I'm going to make a picture. Here's xy. Again, I'm going to draw in two lines, arrows, but I'm going to show that these two lines are parallel. So no solution because we have parallel lines. And one thing to know about parallel lines is that they have the same slope. And the last type of solution is infinite solutions. Again, I'm going to draw a little picture. And remember, infinite solutions is when one line is on top of the other line. So when I draw my lines, I'm going to put two sets of arrows, smaller set and a larger set, to show you that this is one line on top of the other. Basically, it's the same line. So they share all possible coordinates x, y. So share all coordinates. And let's put on the line. Share all coordinates on the line. So here we have our definition, characteristics, which is the solution, and then the three types of solutions. Now a non-example is when we would just have one line. So non-example is just one line. Here's our x, here's our y, here's our little lonely line Just one line there. So this is not a system because we need more than one. We need two or more actually. So this is not a system. Another one that's not a system, and you're going to be seeing this next, not next year, but in Algebra 2, which is your junior year when you take your Math Studies 1, is our quadratic function here. That's just one little parabola right here. So if you have just one, it's not a system. Remember, to be a system, you need two or more working together. We're doing linear systems, so we're just going to be sticking with two or more lines. And so for that, we have three types of solutions. So here's your page all filled out. I'm trying to get this centered so you can see everything. I hope this helped. If you have any questions, raise your hand and I'll be over. Thank you.